Okay. Take some time, but we're getting there. Okay. So we are live on YouTube now, and it's my pleasure to end the statistics seminar for this semester with James Sweeney. He's an associate professor at the University of Limerick, Department of Mathematics and Statistics. He got his PhD in Dublin, and as you will see, he knows some of our colleagues in the department. He has this connection. He has been to Bello. I just learned that just talking right now. I didn't recall that. He has expertise in Bayesian statistics, spatial statistics, pharmaceutical clinical trial designs, and many other interests. So, James, thank you very much for accepting my invitation, and it's a pleasure to have you talking to us and for
Great.
for our seminar. The floor is yours. You have maybe 15 minutes and then about 5-10 minutes to questions. Okay.
Yeah, sure, perfect. So thank you very much for the invitation, Marcos. So what I'll talk about, I'll do a brief introduction to myself in a moment, or a little bit of the other stuff that we work on here. But the main tenet of this talk will just be about property price estimation. So the main challenge in this space is actually getting access to data typically. So this talk is not very technical. I mean, within this space, you can fit quite simple models that are very interesting or very interesting results, but frequently the major difficulty is getting data. So most of the research work in this space is concentrated in major cities, less so rural areas. So applications where there's lots and lots of data and people typically fit quite simple models, so linear regression models, fixed effects and things like that. So I'll just talk about that or touch on that in Irish context. So I guess for those of you who aren't familiar with Ireland, we actually have quite a substantial Brazilian population. So many Brazilian PhD students as well. So I think it's about 30,000. So in the context of the geography of the city, so I work here, a place called Limerick or the University of Limerick that's only about 60 years old. And previously I was in Dublin. So the sort of stuff I would have done my PhD on was in statistical climatology. So trying to build models that link pollen compositions to climate variables. So if you can picture kind of a 3D climate space where you're trying to, I suppose, derive a GMRF smoothing prior in 3D space, quite computationally intensive and quite challenging. So interesting stuff. And then since that, I suppose most Irish statisticians typically are focused on applied statistical modeling as opposed to methodological development, although there are exceptions to that. So a lot of the work we do in Limerick would overlap with the interests of the department in UFMG. So things like renewable energy. So we're working on developing wind and solar maps in an Irish context, in spatial infectious disease modeling. So modeling the spread of animal diseases in the Irish cattle herd, which would be a big contributor to the economic prosperity of the country, and then fun things like property price modeling. So things like property price modeling they're kind of fun problems to work on. So hopefully you'll see some interesting things in this. So just before I move on, one thing to say is that we always welcome academic visitors. So we have had PhD students visiting from Sao Paulo, but if you're in Europe anytime, we can always arrange to fund a research visit or a stay at the department. So we'd welcome people visiting. The last plug before I get into the meat of the material is just that we're actually hosting the International Workshop on Statistical Modeling in 2025. So it's in Durham in a number of weeks. So quite a nice conference, focused traditionally on applied statistical modeling as opposed to very technical concepts. So we'd be delighted if anyone makes their way over next summer. Right. So in terms of the talk outline, I'll give you a little bit of an introduction to the motivations for, I suppose, this particular piece of work, which we've had recently published. I'll touch a bit on what is typically done in the space from, I suppose, an economist perspective. So hedonic regression model, quite simple models, linear regression, maybe a random effects approach in sometimes. Very little in terms of incorporating spatial components. And then I'll introduce some richer data sets and some problems that we're kind of considering if people want to kind of collaborate on. Okay, so from a property valuation perspective, it's like the property industry is quite archaic. I'm sure it's the same in Brazil, and in most countries it's the same. So if you need to get a property valued, it typically takes an order of a week, which takes a lot of time in terms of purchasing a property, or if you're a large commercial real estate fund and you have to periodically value all of your properties, this is quite expensive, quite time consuming. From a tax perspective, obviously the government, if you've property-based taxes funding local government, which you do in Ireland, what's intrinsically of interest is some form of site valuation. So if you think of a property as being formed as a constituent of its parts, the quality of the property and where it's located, ideally what we would like to do is value the site as opposed to the property itself. So you could have two sites side by side with different qualities of properties on it. And ideally what we would like is people would pay the same tax as a function of the site valuation, its spatial location. The problem in an Irish context is that's actually hard to do. So what the government do is they levy tax on the value of your property. So if you improve your property, you pay more tax. So if you improve its energy efficiency, you pay more tax, and quite counterintuitive things, but it's quite easy to implement from a government perspective. So the main challenge is the lack of properties that are comparable to your own. So it's quite ad hoc. It's typically based on a nearest neighbor type structure where you might take the least valuable of your neighbors in terms of property sales transactions. Not very efficient, and there's no formalized way to do this. The other thing is if you're thinking of improving your a property or developing it to improve its commercial value, what should you focus on from a home improvement perspective? What is the value add of different property edits? And then of superficial interest, particularly in an Irish context, is why do people lie about their address? I don't know if this is a phenomenon in Brazil, but typically in Dublin, the major city I'll talk about in a little while, people will say that the address of their property is in the neighboring, much more affluent region than where they actually live. And you can do this in a lot of the old European cities that might be 500 or 600 years old, where there's no real definition of boundaries between local areas. So I did a little bit of research on Belo Horizonte, and it said that the Savassi area is very nice, and across the road from Savassi is Serra. So I don't know if people in Serra say they live in Savassi, or if they're selling a property, they say it's in Savassi, but typically this is a phenomenon that you observe worldwide. So I hope I haven't offended anyone. And then of obvious interest in terms of property evaluation, these kind of simple models is, can we identify undervalued properties and engage in a form of arbitrage? But the substantial caveat here is that typically we won't have the depth of data or wealth of data in order to reduce the margin of error, the uncertainty sufficiently to be sure that we have identified an undervalued asset. So technically, this is what you could do with these sorts of models, but there's a substantial caveat with that. Okay, so whenever I give a talk like this, I always like to focus on a local area. I don't know so much about the Belo Horizonte property market, but I found a paper from 2014. So this is by people in the economics department at Belo Horizonte, and they have data from the tax database and some quality of life indicators for kind of 81 contiguous spatial regions. So they consider a couple of different models, kind of linear regression models, and they identified that a spatial autoregressive hierarchical model for apartment prices works well. I think they've quite a rich data set, a lot of repeated sales, which would allow estimation of micro scale variation, and then covariates around the size of the property, the age, and all of the covariate effects are as you'd anticipate. And when we look at this plot, we see like essentially what we have is a proxy for location. This is a spatial model. And as you radiate out from the city center, properties become less valuable. And typically there's some exceptions depending on how much heterogeneity there might be in these spatial random effects, or we see this affluent region here, for example. And this can be much more pronounced in other cities. These are quite high spatial aggregations, essentially. And we have issues like regions where we have no observations of data. Can we borrow information from neighboring spatial locations to somehow, estimate a kind of a mean effect and some associated uncertainty. If I return to an Irish context, so again, as I previously mentioned, most of the data on things like property prices are held by economists who may not be the most statistically sophisticated from a modeling perspective. So our equivalent of a real rich property data source would be this company called DEST, and they'll publish periodic reports from their economists that say that if you live near our transit system, which is this kind of blue line here along the seafront, if you live near that, your property is worth an extra 129,000. But you'll note that there's no adjustment factors here. There's no adjustment for property type, age, quality, and so on. And they also define near as within 5 kilometers. So the city of Dublin is only about 10 kilometers wide. So if you live within 5 kilometers of these transit hubs, I mean, you pretty much everyone in the city lives near one of these. So what they do essentially is a form of aggregation of data. Instead of controlling for the effects of property features, instead they just minimize it to the most frequently observed properties, 2 and 3 bedroom semi-detached properties of a similar size. These would be the affluent areas. I'll come back to that in a second. And then we have the least affluent areas, essentially. In contrast, so in terms of what people do in other regions, some of you may be familiar with Zillow in the States, which is a kind of a property information portal where you can sell properties, rent properties, and so on. And they have quite rich data sources. So they're a stock market listed company that I suppose a prop tech they'd be called. And last time I was at JSM, which would be 2018, they were heavily recruiting at JSM. So I imagine they've quite good people behind the scenes here, quite good spatial modelers, for example, or spatial statisticians. So they've quite rich information on properties, as we'll see in a moment. And what they'll provide is an estimate of the value of a property and quite a small range of uncertainty in terms of that. So quite nice models. They have a lot of information. At this stage, they're probably using some form of image processing to identify quality of properties and so on. So what they would typically have is extraordinarily rich data on the size of a property, where it's located, number of bathrooms, features that are specific to the property that may add value, particular floor types, kitchen finishes, and so on. And then they have lots and lots of information in terms of neighboring properties, comparable homes. But the one real benefit or advantage that they have in the States, from the States perspective, is that there's an awful lot of tax information publicly available. So tax assessments are required by counties. This is human appraisals of a property. They have records of all of these. And then you may have a property that changes hands many times. So there's a lot of repeated measures type data. So you can really, I suppose, look at the microscale spatial variation. So if you look at the number of properties that they may have, of the order of millions, like really, really good accuracy. So 50 to 60% of properties are within 5% of the actual sale price. Their median error is extraordinarily small. Okay, so really, really, really rich data sets, and these statistics are probably, or their models are even more refined, I'd say, in more recent times than what we're seeing here. Right, so to show you how sophisticated we are in an Irish context, this is our equivalent of their very advanced statistical model. So basically, you go to this portal, you put in the number of beds, baths, and whether your property is a garden and its type, and it basically uses some form of nearest neighbors where it trawls a data set, quite a wide margin of uncertainty, and so on. And from that, evaluates your tax. So not very useful, just in control from many different features of a property. And we may have areas of the city where there's quite a low turnover of property. And as a result, the variability would be extraordinarily high. Something of particular interest in a Dublin context is, and from a statistical perspective, is having a look at whether there's a bias in the addresses that people specify. So a particularly affluent part of Dublin is an area called Castleknock, and Castleknock would actually be defined as this region here. So this is a motorway that surrounds the city, just traverses it like this. And this is this region called Castleknock. These are other regions called Porterstown, Carpenterstown. It doesn't really matter. But you'll see that this property is about 2 kilometers away from what would be perceived to be Castleknock, but includes Castleknock in its address. So our kind of thesis is that people are doing this or mislabeling their address because they think it adds value to the property. And we do have air codes. We do have zip codes, so you can identify that the property is not actually in this area called Castleknock, but these boundaries are kind of blurred. So what we're interested in is, can we address or can we estimate the bias that may be associated with mislabeling a property? And this can become more extreme when you move outside of Dublin, the major city. So Dublin will be smaller than Belo Horizonte, for example. So here's a property that's 10 kilometers from the nearest big settlement, but it's in an area called Rathcoffey. That doesn't really matter, but it says it's in this area called Maynooth, where there's much more property. And people are probably doing this or engaging in this behavior because they think it will add value or elicit interest, which may drive up the value of a property. Okay, so that's just some context on, I suppose, why we're interested in property valuation. More generally, as we'll see as I go on, most of the tools that are used to value properties at the moment are quite limited in terms of the factors they use. So they might use some form of nearest neighbors. They don't really adjust for bespoke property features that will have a strong impact on price. And typically there's just how well do you predict the mean, as opposed to measuring sources of uncertainty, Zillow being an obvious exception, but they have a huge property market. A particular challenge, at least in an Irish context, is there are a lot of regions where properties very rarely change hands. And so as a result, it's nearly impossible to value them, essentially. So from a property tax perspective, very difficult to value them. But ideally, what we would like to do is describe a statistical model where we can borrow information from neighboring regions or infer the impact of different covariates and their impact on property price. So the remainder of this talk, after quite a long introduction, is do people overpay for a good address? With this mislabeling, if people are mislabeling their property, there's obviously a value to this. Then we have different property types. Apartments are quite rare in an Irish context. It's mostly standalone houses. So what is the premium for a house over an apartment, all else being equal, or a house over a semi-attached house? If you wish to convert your roof structures, how much value does that add for a property? Can we value tax? Similarly, we have a lot of vacant sites that the government want to tax, but there's no way to really value them. Hypothetically, you could put an apartment block on them and value from that perspective. We have an issue with soaring rents. So can we come up with some kind of rent control model and limit inflation some way? So these are kind of essentially, can we build a spatially motivated statistical model that gives us a handle on what the value of a property is? Okay, so the specific challenge that we have here essentially is that our data sets are significantly smaller than would be used by the likes of Zillow. Their data sets are quite clean. So this is a data set provided by a real estate company, which actually for a period in 2018, which actually had about 20,000 observations, 30,000 observations, but there was an awful lot of missing data. So there was only about 5,200 observations with complete data. So the sort of information that's available is the sales date, so when it was sold. So we could probably engage in some form of temporal modeling, maybe at a monthly level. We do have geographic location from a longitude and latitude perspective, which allows us to do a lot of cleaning of the mislabeling and investigate the impact of mislabeling. We also have the local area or local neighborhood. You can think of something like maybe Savassi or Serra or whatever, or regions within that kind of postcode region, as it were. Number of beds, baths, and energy rating. as it were, and then a written description, which is typically what would be missing from other data sets. So I'll give you an example of what we typically have. And we're interested in size, of course, property type. So this is the complete data set we have, which isn't quite rich, or isn't very rich, because it's such a sparse data set over that time frame. We don't even look at temporal models, but towards the end, I'll touch on a richer data set we have where we're exploring some work in that space. Okay, so this is just a map of the Dublin metropolitan area. These are these 5,208 properties we have. So the affluent or really, really prestigious areas to live are, as you can imagine, along the seafront. So be quite affluent along the seafront, along here where there's a kind of a rail system that traverses the city. There's actually a river that splits the city through here, which introduces an element of non-stationarity from a spatial perspective. I'll touch on that a little bit later. And we just have this ring road that goes around the city with the airport up near here. So there's many features that that impact on the value of a property. If we look at it from a price information perspective, and we standardize by looking at price per square meter, again, I suppose, as I said, what you can see is most of the valuable property is along the seafront. So this is south of the city, south of the river. The south side would be regarded as the most affluent part of Dublin. The historic core is north of the river, with some pockets of extreme affluence out here along the seafront, up in this region called Malahide. And then there are pockets, so which kind of required, I suppose, aspects of modeling skills. So this here in particular is that region that I called Castleknock. So quite an affluent region near a big park, and the properties in the surrounding region are much cheaper per square meter. So what you see is a blurring of this region into the neighboring region where people claim to be from this more affluent region. So this is kind of, I suppose, what the data looks like from a valuation perspective. And then we can spit it out into postcodes, like these PUs that you have in Belo Horizonte. So if your postcode is south of the river, you have an even numbered postcode. If you're north of the river, you have an odd numbered postcode. That's kind of the dichotomy. And there are a couple of, I suppose, niche things to observe. So every postcode is numbered a letter then a number, with the exception of one here. This is D6W. So this is where this whole region became so populous that they wanted to split it in two. So the original proposal was to call this region Dublin D26. But unfortunately, this is a much less affluent region here, D24. So the people who lived here refused to be called D26, and instead it became D6 with a W signifying west. Okay, so again, lending weight to this inference that there must be some value in people saying they have a postcode. So a big thing in a Dublin context is to say that you have a Dublin 4 postcode. This is, people will pay more money, is our hypothesis for something like that. But as you radiate out from the city centre, property on average becomes less expensive per square meter, as you can imagine. So I'll come back to that later on. Okay, I didn't mean so. Okay, so if we look at those postcodes again, just from I suppose a quartiles perspective, what you can see is there's this kind of jagged structure. So this would be odd numbered postcode, even, odd, even, odd. So these are all around the city centre, either side of the river. And what you can see is those on the south typically command a much greater price premium than those on the north of the river. And there's also a lot of heterogeneity in, I suppose, we're not adjusting for property features, types, and all that. So a lot of that variability is incorporated by this mix of property types. But as you move away from the city centre, basically property prices per square meter decline. And then this is in the kind of suburban areas where big houses, big gardens, or very affluent parts of the city down to the south of the city. But in principle, it would make sense that spatially, as you move away from the city centre, properties become cheaper or cheaper per square meter. So sorry, I'm after Xing that. Okay, here we go. Right. So I just showed you the postcodes. Each of those postcodes can actually be broken into local areas themselves. And even within a postcode, people may mislabel their address. So, for example, a question we might be interested in is this particular area, Dublin 6, I'll return to later on. There's 5 different local areas within this postcode. Could we identify which one is the most affluent or the most desirable from our model, and what that margin of desirability is? So intrinsically, what we would like to do is estimate the postcode effect. So north of the river is cheaper than south of the river. And within each postcode, estimate the impact of each of these labels. Okay. From a data cleaning perspective, because there's so much mislabeling of data, there's an awful lot of cleaning. Most of it can't be automated. It's actually quite manual. So I had a number of undergrads kind of engage with this as part of a class exercise. So we might have a local area called Rathfarnham, and people classify it in actually 3 different postcodes. It's quite a big region. Again, blurred boundary lines. Or we have a region called Terenure, where again, people use a number of different postcodes. So quite slow, laborious work. A lot of it is visualizing things on maps and identifying, I suppose, what we would classify as Rathfarnham, for example. Okay, right. So we know where property is. We know its price. We know its size, beds, bats. Obviously, there's a whole host of other features that impact on the value of a property that we don't have access to. But we can, I suppose, glean some information from property ads. So we can take this kind of online portal where we have a property description, if there is one, and what we can do is scrape this for keywords that we think are useful or potentially add or take value. So this is an apartment that's in the center of Dublin in a touristic area. It's duplex, so dual aspect, faces south and west or whatever. It's corner, it's a penthouse. So these are all features that we can identify in conjunction with property agents that are desirable. And then we can just scrape all this text in a rather unsophisticated way. Just look for keywords or different versions of the same words. So south facing is a really nice aspect to have because you get a lot of sun in the morning. So we basically trawl all these property ads, these 5,208, to identify these kind of binary indicator variables. So have they converted their roof space to additional habitation space? Do they have parking? Now, that's an interesting one because if you live 20 kilometers from the city, everyone is parking, or even 5 kilometers. So what we're more interested in here is the value of parking close to the city centre. So if you're selling a parking space with your property, how much will it be worth? Development potential is if you could build a house in your garden and sell it, things like that. And then there's other things that are specific to an Irish context, whether your property is open plan, does it have a fireplace, whether it is central heating, strange enough, probably not such a phenomenon in Brazil. And other things that we would be interested in, particularly from an apartment perspective. Is it a ground floor, first floor, penthouse? And particularly, has this property been refurbished, renovated, upgraded? So what is the value add of upgrading a property before you put it on the market if you're a real estate developer? In terms of property types, we have 2, 4, 6. So we've 7 different types of property: apartments, standalone houses, kind of apartments above apartments, apartment houses. I don't know if there's an equivalent in Brazil. End of terrace, if you have a line of houses, and so on. And we've quite a mix of these property types across each of the postcodes. Typically towards the city centre is where most of the apartments are located. As you move further out, it's much more semi-detached houses and detached houses. Okay, and again, you'll see that the median price per property declines as you move further away from the city centre. So, like, our data set isn't really rich enough to try and identify, whether there is an interaction between each of these property types and these different regions, but or these different postcode regions. But it would be inferred that there probably is. So, for example, if you have a detached house in the middle of the city, that's obviously much more value from a relative perspective than a detached house out in the suburbs. Okay, so I'm going to set myself the really simplistic task of beating a simple linear regression model, essentially. So From an economist perspective, they would look at these sort of problems or consider them to be hedonic pricing models. So the value of a property, you can disentangle it into characteristics of its location, so spatial characteristics, neighborhood characteristics in terms of what amenities are on offer nearby, and then environmental characteristics from quality of the air, parks, and so on. So typically within this space, we model the log selling price per square meter because the residual behavior is typically quite good. You can typically assume a Gaussian likelihood for the observational data. Typically, again, because the data sets aren't that rich, you end up with this kind of dichotomy where people either fit linear regression models or use AI and machine learning and say, look, I fit a neural net to this rich data set. There's very little in the middle. So Alan Gilfan has a paper in 04 or a couple of papers in the early 2000s where they look at different aspects of spatial models, so spatially varying coefficients, but typically assuming linear models for many of the covariate effects. So these models would work well if you had all of the information available that describe the value of a property, but of course we typically don't have this, which introduces spatial effects in the residuals. So from a simplistic model perspective, we just have price per square meter, assuming a Gaussian likelihood, some fixed effects that we've already seen, beds, baths, these binary indicator variables about quality of finish. And what I've actually included here are two random effects. So one for postcode, which we could model as a fixed effect and employ some constraint around, in terms of instead of making postcodes relative to one of the postcodes, just imply a constraint towards the mean. So we could do something like that. And similarly on type, but I want to extend this in a little while to, including random effects for local locations, which you could never scale a model like this from a fixed effects perspective. The data isn't rich enough. So quite a simple model. You can fit this using Limmer in R or any kind of a random effects modeling software. And then similarly, there's no real onerous computational aspects here, no huge variance matrix to invert. So any of the standard software packages, JAGs, or if you don't want to write your own samplers, JAGs, any of these will work well. So if we fit a model like this, a lot of the inferences make sense. So for example, with this simplistic kind of model, the effect of parking is that it reduces the value of a property per square meter, but this again is a proxy for spatial location. We see a lot of the variables. So again, this is a bad idea, but this is typically what's done within the economic space. So linear effect for beds, you wouldn't imagine that the value of beds would be linear indefinitely. Similarly for bats, energy is a categorical variable, but that is considered on an ordinal scale. But again, this kind of simple model is not pulling out the structure. But it is identifying things that are of interest, like development potential, so adding 5% to the value of a property and so on. But what we see essentially is that the expected price per meter squared is for €4,700. And if we had to value a three bed, one bath house, it would be €421,000. And then we would adjust this for its postcode and things like that. We can look at the effective type. So what is the premium for detached property versus something like an apartment? So on the order of 20% more for a detached property than an apartment. And then with some of these, or a detached property versus a semi-detached property, that premium is of the order of 10%. But so these kind of make sense and, I think align with what we would expect. What we see when we look at the postcode, so the postcodes here are acting as a proxy for spatial location. So what we see, of course, is that we get quite large relative effects here in the city center. So I modeled price per square meter on the log scale. So when I exponentiate back, we just get a multiplying factor. So what it's saying is that all other things being equal, properties here are worth 50% more than, say, a property here, for example. So quite substantial differences, but at quite a coarse areal level. There's no spatial continuity is not modeled here. We're not imposing something like a car prior on neighboring regions. So quite a simplistic model. but of course, then it should be simple to beat it. From a prediction accuracy perspective, when we looked at those Zillow data sets where they had 2 million observations, within 5% error, they had maybe 60% of observations. Here we have 25%, quite a lot of tail variation. And the median error is of the order of 11%. So if a property is worth €500,000, we're out by, plus or minus 50,000 on average, which is obviously a lot. You're not going to make any money from a statistical arbitrage perspective. Okay, so what we see in this simplistic model, and what is often not addressed in these kind of hedonic regression models, is that there's a lot of spatial variation left over, structure left over. So there's neighborhood characteristics we possibly can't describe. Also, simplistic assumptions like linear effects for beds and baths are obviously overly simplistic. So what we're going to do is we're going to have, I'm going to introduce a spatial random field. Now, my hypothesis is that if you introduce a spatial random field, then the impact of postcodes should disappear, because if you're modeling the point reference location of a property and estimating its spatial effect, then there should be no impact of postcode. And similarly, if you have a label such as local area, that also should not be significant, because we're modeling properties at a point reference level. So if they are statistically significant, that would indicate that there is a bias or a value to mislabeling the location of your property. So we're going to incorporate a spatial random field. There's lots of different types we could choose. Like, we know in principle that due to the geography of the city, a stationary isotropic spatial random field, doesn't really make sense, but we only have 5,000 observations. So what we'll typically assume, or what we'll do here, is we'll just choose an exponential covariance function, quite simple. We'll impose a constraint that it's quite smooth, because we're going to have multiple layers of spatial effects. So quite coarse area level data from a postcode perspective, then less coarse but still quite coarse neighborhood type data, and then point reference data from this continuous spatial variation perspective. So our general model here, we're just going to add in, where are we? Okay, yeah, sorry, it was there. So again, we have all of the fixed effects we had earlier with a slight degree more of sophistication. So we're going to impose we're going to model the effect of beds, baths, and so on using a smoothly varying function. Here we'll just use a p-spline, nothing too complex. And what we're going to do is model the continuous spatial variation with this, or via spatial random field with an exponential covariance structure. And I've added in some additional random effects which are around this local area. So if we were modeling this from a fixed effects perspective, or including all of these from fixed effects perspective, then we don't have near enough data. Now, the thing about this is that because we don't have a lot of data, a lot of these random effects are going to essentially look like noise. But there are some that will appear out that are of interest. But in general, this is our slightly more advanced model where we're going to consider spatial proximity. So penalized splines on the effects, and then again random effects for each of these with a sum to zero constraint in terms of identifiability. We'll try and ensure that the GP is quite smooth so that we can disentangle these different spatial levels. So again, quite simple models, nothing really complex here. I mean, we've a covariance matrix of the order of 5,000 by 5,000, not that fast to invert. We could make these things more efficient, but you can use something like Orstan or JAGS, and as slow as they are, we don't really mind, essentially. Okay, so if we fit a model like that, it works really well because we've a Gaussian likelihood, everything mixed very well. We can integrate out the spatial effects, reduce the complexity of the problem, so on. So if we look at a model like this, what we can disentangle more, more precisely is the effect of differing covariates. So, for example, if you have a car parking space within the city centre, so we define that as within 2 kilometers of the city centre, that appears to add around 5% to the value of a property. If you can develop the property, if you could build a house in the garden, that adds about 5%. Things like whether it has a garage is quite valuable. Ground floor apartments are downweighted, of course, less desirable than a penthouse apartment. So penthouse apartment, the adjusting factor is about 15% extra versus the other apartments in the block that aren't ground floor, for example. And then there's a small, slight effect of the orientation of the property, whether it's south facing. And this appears to suggest that the value add, or if you're refurbishing a property and putting it for sale, that appears to add around 5% to the value of it. So the previous kind of inelegant model, which estimated the expected asking price to be about 420,000, this is about 358,000. And of course, we would then subsequently adjust it for its location, different local areas, postcodes, and so on. Okay, so from a sanity check perspective, these are kind of, I suppose, how I think about it is that if you have a real estate agent who has been in real estate appraisal for 50 years, they're probably, can you create a statistical model that will do better than their innate intuition? And I would say probably not. So these are kind of the effects estimated for each of the features, on the previous slide from a real estate appraiser. So things like the impact of beds, obviously they don't have the concept of splines or 14-bed properties. So they've quite coarse effects, but things like, let's see, there was one I was looking at. So parking adds about 5%, which is what we estimate. So these are, so sorry, I suppose what I'm trying to say is that a lot of our estimates align with what real estate appraisers would expect. From the perspective of the effect or the impact of the type of property, we wouldn't imagine that these would differ much from that simple kind of linear regression model, because we've so much information available to estimate these covariates or each of these effects. And equally, they're kind of a proxy, or if there's enough spread in these properties across the region of Dublin, then their locational aspects aren't really going to impact on them. So we can see this understandable, I suppose, decline in property depending on the property type. So this is a detached house, semi-detached houses that are joined together in a terrace. Typically more you see towards the city centre, and then the least desirable is the duplex, and so on. So I'm sure quite different to Belo Horizonte. From an energy rating perspective, there's quite a big push in Europe, particularly to make properties more energy efficient. So we use less natural gas, buy less stuff from Russia, really, to be honest. So what we see is an A-rated property, on average, is worth about 3% to 4% more per square meter than a C or D-rated property, which would be the typical housing stock that's in the city. So this kind of makes sense. If you have a property worth $500,000, at the moment it costs about 20 to 30,000 to increase or improve the energy efficiency of it, and that's borne out by these kind of covariate estimates. We can look at the effect of bats, which typically are traditionally chosen to be modeled as a linear function of the number of bats. These are large properties like old historic houses that are probably divided into a number of apartments and typically in bad condition, which is why we imagine with an increasing number of bats, the properties are worth less per square meter. Equally, typically properties, if they're a standalone house that someone lives in with this ostentatious number of bathrooms, typically far from the city centre because it's a poor use of valuable real estate. So this kind of, again, corresponds with what we would think. Similarly, from a bats perspective, so up until about our beds perspective, up until about 4 beds, the impact of an additional bedroom is linear in terms of its effect or value add to price. And once you get above 4, which would be as much as you need for a traditional family in Ireland, it just plateaus off. And again, these are kind of old historic houses or very rich houses in the affluent areas, which explains this kind of degree or level of variability. Something that is of interest earlier on is, so what is the impact of postcode? Again, my hypothesis is if we impose this continuous spatial random effect at a point reference level, then the effect of postcode should just disappear. But even in spite of that, what we're seeing here is that there is a discernible trend or detectable trend in terms of these postcode scaling factors. So the least affluent parts of the city are odd numbered, the more affluent parts are even numbered. So what we can see is that even after accounting for the geographic coordinates of a property, there still appears to be a 6% premium for it being in Dublin 2, 5% for it being in Dublin 4. Dublin 6 is where all the tech people live in Dublin. So a substantial premium from there as they exercise their stock options and buy property. And then there's parts of the city that are much less affluent, that typically on the north side or on the odd side. Something that's of interest here in particular are these two areas here. So Dublin 14 and Dublin 16. So these are areas with quite blurred boundaries, quite large regions, and you do see a lot of blurring of property addresses into neighboring postcode regions. So for those properties at those margins, we identify a distinct change or a premium of about 5%. Right. So we also have modeled local areas. Again, we only have 5,000 observations or thereabouts. So I think we've encoded here maybe a couple of hundred local areas. We'd imagine that there's so many parameters here that the uncertainty will be large. We won't identify anything as being statistically significant, but the premium parts of the city, areas such as Castleknock, it would, from the perspective of the credible intervals, obviously none of them are statistically significant or most include 0, but it's not a coincidence or an accident that pretty much for all of the regions of the city that would be regarded as desirable from a local area perspective, all of their point estimates are positive. Less desirable areas, their point estimates are negative. But again, if we speak to our earlier hypothesis that if we're modeling the spatial variation at the property level, then this should just be complete random noise, as should the postcode labeling. Some of the fun things we can do with this additional layer of random effects is within a certain postcode, we can infer which is the most desirable region. So again, controlling for spatial location, the only thing that's left over is label. It appears that Rathgar, which is where all the embassies are within Dublin 6, there appears to be a slight premium for living in that part of this postcode area than the other ones where they just look like random noise. Right, so from a spatial random effect perspective, so this underlying spatial random field that we've imposed this kind of smoothness constraint on, just so we can disentangle it from the postcode and local areas effects, it pretty much pulls out what you'd imagine from the perspective of the very affluent parts of the city are in red, so along the seafront, and we see this pocket of expensive real estate per square meter in this area called Castleknock. So all along the seafront here would be extremely affluent. A substantial drawback to this model, of course, is assuming a stationary isotopic structure in the covariance function. So what we're borrowing information across the bay, which we shouldn't. And that's something I'll touch on later from a non-stationary perspective. So from a price prediction perspective, works quite well. We do see an increase in heterogeneity in terms of the variance estimates as you fan out. But all in all, we would be happy enough with the estimates. Below about 1.5 million. Above that, I'm not showing you. They go crazy. And in terms of prediction accuracy, so we have a 10% improvement in prediction accuracy below 5%. Still way off what Zillow would get with 50 to 60%. But our median error is reduced by about 2% using this model versus a simple hedonic regression model. Now, I mentioned before that we can correct the data for mislabeling. So if I update the data set, in the previous models I showed you, I used the labels that were provided by the people selling their properties. So this is for the correct postcode. So once you actually correct the postcodes, this variability that comes from mislabeling goes into the spatial random field. And what we actually see is there's not really, there's no discernible trend in the postcode impact. Okay, so this kind of shows that there is a benefit in mislabeling where your property is, or there does appear to be a premium in terms of lying about where it is. And this is why people do that. Even correcting this mislabeling, there's a slight reduction in the quality of the accuracy of, say, the proportion of properties that are within 5% error, but our median error reduces by about 1% again. Okay, so down to about 8.2%. Okay, so I've 3 more slides, which are kind of a little bit more interesting. But so we've basically constructed a model here that can be used to estimate property tax properly. So controlling for each of the different features of a property, we don't have age and things like that, but size, beds, bats. We can see the impact of energy rating, that there are reasons why people mislabel their property, because there is a premium associated with saying you live in a certain region, which is a proxy for affluence. So a simplified version of what I've presented here was published a while ago, but recently, I suppose, in paper form, but using much simpler models. So just using generalized additive models, not going to this depth of, I suppose, spatial investigation. So simpler model, but many of the insights are broadly the same. So if you're interested in reading more about that, that's available at that DOI. Where we would like to go with this, so because even in spite of it being a small data set, the results seem quite promising. A real estate company have provided us with 30,000 transactions for 2022, where they've actually cleaned up a lot of the data. We've text descriptions for all of the properties. And this is actually at a nationwide level as opposed to just Dublin. Now this becomes an interesting modeling challenge, because we would imagine that the impact of beds, property types, are quite different geographically as you fan out across the country. So if you have a detached 2-story property in the middle of a city, that's obviously more valuable than a property in the middle of nowhere where everything is a detached house. So it introduces a degree of complexity in terms of how we model the impact of these different covariates, beds, bats, all of these. So what I suppose one proposal is you could look at spatially varying coefficient models, but even with 30,000 transactions, do we have sufficient wealth of information to disentangle the spatial confounding between location, as well as encoding spatial location in these covariates? That's one challenge, or one substantial challenge. The other thing we can look at is modeling through time, a simple autoregressive type proposal, just to have a simple model for the effective time. But this company have maybe, I don't know, 250,000 data points over a number of years. So it would be interesting to get that whole data set and see what we could do. The real challenge here, or the real benefit of, say, particularly adopting a spatial modeling perspective, is that there are parts of the country where property turnover is extremely low. So if you wanted to value property from a tax perspective in those regions, it would hopefully be by borrowing information on the characteristics of properties, impacts of beds and bats, and then some kind of land value that's interpolated from this spatial random field. So lots of challenges here. One proposal, so interested to hear your thoughts, or if anyone has any suggestions. Instead of going for extreme overkill in terms of the model, we do have quite rich census data. So the same year as we have the data for the house prices, we have a nationwide census carried out where basically the country is broken up into households no more than 200 people. So there's something like 3,000 small areas here. And for each of those, we have indicators for education attainment, property types, whether they own their property. So one proposal at the moment is just to take that data, which is a mix of numerical and categorical data, employ some sort of clustering algorithm to identify maybe 5 or 6 different clusters. For each of those 5 or 6 clusters, fit separate covariate effect models, effects of property. We'd imagine that from an affluence perspective and high education attainment, this would be concentrated in the richer parts of the major cities on this plot. So what we kind of are proposing at the moment, but we haven't really looked at yet, is to have a continuous spatial field and then just adjustment factors on top of that, which will depend on the cluster that the region you are in is associated with. So that's kind of one proposal that might be more parsimonious than a super complex overkill model. And then the last thing, so I've spelt non-stationarity wrong, which is poor for an native English speaker. But a real challenge here is, as I mentioned earlier, there is this kind of boundary effect within the city. So north of the river is considered to be less affluent than south of the river. So there actually is a boundary effect of that river. Or if you look across the bay, considering a stationary isotropic covariance function, you're borrowing information across a body of water which you shouldn't. So we could look at encoding some kind of boundary conditions, so distance from the sea, potentially introduce non-stationarity using the kind of inlet SPD approach, which is probably kind of overkill, really, to be honest. Or it's not clear to me that you can like precisely estimate those non-stationarity impacts without pushing variability somewhere else and making some other covariates important that are not. From a general perspective, even with 30,000 observations, Gaussian processes are probably less tenable. One thing we could look at is, nearest neighbor Gaussian processes, things like that. It's just whether we will, what sort of neighborhood structure would be required to estimate the spatial range, for example, and how much we would restrict that. So these are kind of the things that we're considering at the moment, and how we might progress this and do something that's a little bit more elegant. So if anyone has any thoughts, I would welcome them. And I've probably gone way over time. Hopefully you found that interesting. I'll finish up there. And if anyone has any questions, happy to take them.
Thank you, James. Let's see if anyone else has questions. The end of your talk is very interesting because it intersects with things I'm doing, actually. So
Okay,
I'll have
cool.
comments on that. And that's by chance, right? So one question I have, before I go to the details of this last two slides, basically, is you put a spatial random effect, and you have covariates that are highly spatially dependent, right? Depending on the structure of the city, size of the house, they're probably not going to be downtown. So, if you have a very big house, probably not in the middle of the city and so on. So your covariates somehow are related with space as well. And that might create some spatial confounding between the effect of the covariate and these unmeasured effects that you're trying to control, with the spatial random effect. And then there's a lot of discussion on this, saying you should do this or you shouldn't do that, what you expect and how to handle spatial confounding. And basically it's a mess, right?
Absolutely. It tallies with some of your previous work, or the seminar you did previously, trying to disentangle those, right?
Yeah, but it really, so my conclusion on this is, depending on what you believe it's going on in your problem, then you should go to an approach to untangle this in some way, but it's probably there. And it might confuse your, when you get those change of estimates for your betas, for the coefficients. It will be interesting that you're controlling for this, maybe, because sometimes you get over optimistic, or even the other way around, you get very large intervals, and it might be significant in some sense, and who knows. So just a suggestion, something you may look at,
of course,
when you analyze this.
Well, even from the perspective of so this just tallies with what you're saying. So the reason there's so much variation here is that this is basically really old properties with a large number of bedrooms, poorly maintained in the center of the city, and these are large properties in affluent areas with tons of bedrooms that are super rich. So there is that confounding between spatial location and the impact of beds. And, it tallies with what you're saying in terms of it's just borne out by excessive variation.
Yeah. So the second thing is, when that slide, we are just hopefully finishing the last round of review for a paper where we are trying to get to estimate the price of selling houses in Beijing.
Cool.
We propose to use INLA plus the NNGP type of approach on INLA, and we ran it for, say, 36,000 observations and 12,000 zip codes. The way it's structured, the apartments are on zip codes, and those D you have, right? And it runs maybe in 10, 12 hours in a regular computer. So it scales nicely for, and they always spatially vary coefficients as well.
Yeah, okay.
So
Okay, that sounds really interesting.
we have the mean and spatially vary coefficients for 36,000 observations and about um, I mean 12,000 zip codes. So it scales nicely, and hopefully this will be done, and we have the code for that at GitHub. So if you
Ah,
were
cool.
interested, I think we can share.
Yeah, so
The,
I'll definitely follow up with you on that. I guess what I'd like to do. So this is kind of 1 year's worth of data where we can try and do something a little bit more sophisticated or a bit more elegant from a modeling perspective. I guess that what I observe in looking at the literature is that most of the applications typically involve major cities, right? So Beijing, major city, probably some repeated sales within an apartment block, or the original Gelfand paper that looks at Singapore as a,
that's
yeah,
exactly the paper we're extending actually,
yeah,
because
yeah.
now we go for generalized linear models, not only normal Gaussian models, and we
Okay.
put the block and NGP approach to scale it up, and we matched with Inla and so on and so
Yeah.
forth. And that paper from Gelfand, exactly the one we extended now for
Yeah.
to
Okay.
do
Cool.
this.
Yeah. Yeah. Let's.
So
I look forward to seeing that.
yeah, I think it's useful in some sense, you know.
Yeah.
And well, but the next one, I have no idea how to handle it. Like the problem with the concerns in at least with the NNGP approach, it's not clear to me how. Even though the you approximate a stationary covariance function with a non-stationary one, that's the what NNGP does. It's not
Mm.
clear how to control that non-stationary one for whatever you like, you know.
Yeah.
So that's still for me
It's
an open question how to include this kind of
Yeah. Well, I
important
mean,
problem.
if you consider I suppose if you consider a one metropolitan city like Dublin here, I mean, you could encode this boundary coefficient where information isn't borrowed across the river, or maybe there's multiple spatial layers where there is a kind of a barrier imposed. In some respects. So it would be interesting to see, even if something as coarse as just kind of a boundary layer where information wasn't borrowed on the spatial field across these two boundaries, but other things like covariate effects, beds, bats, were. It would be interesting to see if that made a difference, or if there was a lot more, I guess going to that level of um, model complexity is actually valuable, or as to what degree of improvement it would give you.
Yeah. So interesting, right? Because you have a very applied problem where it involves a lot of money and public interest and like even government because it's tax related, right?
Yeah, yeah.
And it's challenging in the statistical side because if you put a very good black box kind of neural network, okay, nice, maybe you get a very nice prediction, but it's very hard to extract like all the interpretation you give for the parameters and how
So
they affect and everything.
yeah,
You may get the final number precise, but this in between gets lost, right? So
yeah, of course. So you can, so yeah, I suppose to your point, so you can apply a random forest to this data set and you will get roughly comparable levels of mean prediction accuracy to this complicated spatial model. But the uncertainty estimates are quite poor. And as well as that, once you move beyond a major city, once you move out into rural areas where there's property turnover is a lot lower, there's a lot less comparable properties, then they just don't work. And that is, I guess, my hypothesis why most of the algorithms you see in this space or papers that are published focus on major cities where there's lots of data, repeat sales data, so on. So I think there is an open question there about how well some of these approaches scale to a national perspective, because you don't want to be fitting a model on a city by city perspective, or so some work has been done on like geographically weighted regression approaches. I think there's the paper in the Journal of Real Estate Finance, maybe 2020, by some guys in NTNU, where they cluster Oslo into certain cohorts and then fit models from that perspective. So it works really well. I mean, their prediction error is quite small, but again, it's not clear to me that that would scale well outside of the city. And in an Irish context, 1/4 of the population live in the major city, so that's 3/4 that need to pay tax, right? So these kind of black box approaches won't work.
Interesting. So let me see on YouTube if anyone else has questions. Let me
Yeah,
see
go
if I
for
can
it.
find it. Well, people watching. I can't find the chat anymore. I've been having I don't know what happened. I can't see it now. Well, anyways, so I think we are all set. We are on time anyway. So thank you for accepting my invitation. Congratulations for the young baby, and
Thank you.
we see each other around. Hopefully,
Yeah, well,
at
no,
some
so
point.
absolutely. I think, I suppose, as I mentioned before, there's a lot of overlaps. Well, particularly in our research interests, but I think at UFMG and other members of the department. So, I mean, look, what we're kind of looking at now with Ali Abalasani, scan
Yeah.
statistics for wind predictions. So,
Did he
you've
get
already done
there
some
at
work in that
all?
space. No, we're still waiting on a visa, but
It's crazy. Yeah,
eventually
last
he
time I
will.
spoke to him, he was like, "I'm still waiting on the visa."
Yeah,
I'm working with him in
it's
a paper as well, and then
Oh, great.
I
So, like,
we talked
really,
a
really
little bit.
looking forward to Ali coming. So, yeah, no, I'll definitely touch base again with you soon. And I mean, I don't know if you have a preprint of that paper in the last round of reviews available. If you don't, I'm happy to wait until it's accepted, whatever. That's not a problem. But
I don't
I'd
have
love to
it.
see it.
I'm hoping it's the
Yeah,
last round.
that's
I'm
okay.
very
Yeah,
confident
yeah,
that will be the last
that's
round.
that's no
But if
problem.
not, I can prepare one for you. I just put it on archive. I don't care. I can
Yeah,
ask my
no, I'll,
co-authors if I can just submit it there. It
yeah, no
should be
worries.
fine.
I'll chase it up with you separately. But look, many thanks for your time, and have a nice Friday in Belo Horizonte.
Thank you. Thank you. Have a good one. Bye bye.
Bye bye. Thank you very
Ciao,
much. Bye bye.
gente. Let me say bye to the students. Bye, everybody, and have a nice vacation because we are at the last seminar of the semester and we start again next